everybody, today we're going to talk about half-angle formulas. In this video, after we develop the formulas, I'm going to talk about finding the exact value of an expression when I'm given an angle that's either in degrees or radians. To start us off, we're going to look back at our reduction formulas. We previously found out that sine squared theta can be expressed as 1 minus cosine 2 theta over 2. Cosine squared theta can be expressed as 1 plus cosine 2 theta over 2, and tangent squared theta can be 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. What I want to do is replace theta with alpha over 2. Notice that the substitution occurs on both the left and the right side of the equation. On the right side of the equation, we'll cancel the 2's, which gives us these reduced formulas. What I want to do is find a formula for sine alpha over 2, cosine alpha over 2, and tangent of alpha over 2. Right now, we have sine squared alpha over 2, cosine squared alpha over 2, and tangent squared alpha over 2. To get rid of the square, I'm going to take the square root of both sides of each equation. This gives us our half-angle formulas. Remember, we want to put on the plus or minus outside of the square root to show that we could have two possible solutions. Sine alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 2. Cosine alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha over 2. The plus or minus sign will be determined by the quadrant of the angle of alpha over 2. Our last formula is tangent alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Now that we have our formulas, let's solve a few problems. We'll start with using the half-angle formula to find the exact value of sine of 195. The first thing we should decide is, will this be a positive or negative value? 195 degrees is in the third quadrant, and we know that sine is negative in quadrant 3. I'm going to rewrite the sine of 195 as the sine of 2 times 195 over 2. Then I'll multiply 2 times 95 to get 390. Then let me quickly remind you our formula will be sine alpha over 2 plus or minus the square root of 1 minus cosine alpha over 2. In this case, alpha is equal to 390 degrees. We have sine of 390 over 2 is equal to plus or minus the square root of 1 minus cosine of 390 over 2. 390 is equivalent to 30 degrees, so let's rewrite this as plus or minus the square root of 1 minus the cosine of 30 over 2. Cosine of 30 is the square root of 3 over 2. Now I have plus or minus the square root of 1 minus the square root of 3 over 2 divided by 2. I want to get rid of this complex fraction, and I want to rationalize the denominator. My first step will be to look at the numerator. I want to combine the 1 and the negative square root of 3 over 2. I'm going to turn the 1 into 2 over 2, and then I'll combine the numerators. Now I have plus or minus the square root of 2 minus the square root of 3 over 2 divided by 2. I can multiply the denominators together, which gives me plus or minus the square root of 2 minus the square root of 3 over 2 times 2. We know 2 times 2 is equal to 4. Then I can apply the square root to the numerator and the denominator separately. In the numerator, I have the square root of 2 minus the square root of 3, and the denominator, the square root of 4, reduces to 2. We've already said that we know sine is negative in quadrant 3, so we can get rid of the plus or minus and just write it as minus. This might look a little bit ugly, but this is our final solution. We found that the sine of 195 degrees is equal to negative the square root of 2 minus the square root of 3 over 2. Before I move on to the next problem, I want to give you two more equations for the tangent of alpha over 2. This time I'm not going to derive them. I think we've probably done that enough. I'm just going to tell you that tan alpha over 2 could be expressed as 1 minus the cosine of alpha over the sine of alpha, or you could also express it as the sine of alpha over 1 plus the cosine of alpha. We're asked to use the half-angle formulas to find the exact value of tangent of 9 pi over 8. Once again, I'll start by asking, is this a positive or negative value? 9 pi over 8 is just a little bit bigger than pi, which says we're in the third quadrant. In quadrant 3, tangent is positive. Next, I'm going to express 9 pi over 8 as 2 times 9 pi over 8 over 2. The 2 goes into the 8 to give me 9 pi over 4 divided by 2. So before we go any farther, I want you to think about what our reference angle is for 9 pi over 4. 9 pi over 4 is bigger than 2 pi. So what happened? We went all the way around and we're back to pi over 4. For this expression, I'm going to use the formula that tan alpha over 2 is equal to 1 minus cosine of alpha or over the sine of alpha. Because I know my reference angle is pi over 4, I'm going to use that in my equation. Now I have that the tangent of 9 pi over 4 divided by 2 is equal to 1 minus the cosine of pi over 4 divided by the sine of pi over 4. Both sine and cosine will be equal to the square root of 2 over 2. This tells me I have 1 minus the square root of 2 over 2 divided by the square root of 2 over 2. Just like in our previous problem, we want to rationalize the denominator and get rid of the complex fraction. I'll start with the 1 in the numerator and write that as 2 over 2. Then I can combine the numerator to get 2 minus the square root of 2 over 2. And I'm going to flip the denominator to become 2 over the square root of 2. I can cancel the 2's and rewrite my fraction as 2 minus the square root of 2 over the square root of 2. Instead of rationalizing the denominator probably the way you expect me to do, I'm going to distribute the square root of 2 to the two terms in the numerator. This gives me 2 over the square root of 2 minus the square root of 2 over the square root of 2. 2 over the square root of 2 reduces to the square root of 2. Then I have minus the square root of 2 over the square root of 2, which reduces to 1. As you're doing these problems and you see that there are a lot of little pieces to them, just take your time and go slow. Another thing you can do is check your work. So let me show you what I mean by checking your work. Remember we started with the tangent of 9 pi over 8, and we ended by saying is equal to the square root of 2 minus 1. If I go to Desmos, I can check my solution. The first thing I'm going to do is check my settings. My settings are in radians, which is where I want to be. I'm going to type in tangent, then I'm going to put in 9 pi divided by 8, and it says the answer is 0.4142. Then I'll go to the next line. I'll type the square root of 2 minus 1, which also says 0.4142. The reason we can't just directly go to Desmos to get the answer is we wouldn't get the exact answer by just putting in 9 pi over 8. It's going to give us some decimal approximation. At least we can check the number part by going to Desmos and verifying that the numeric part is right. Then you can check the sign of the value based on the quadrant that we're given.